Hello ladies, it's Mr. Sullivan. Today we're going to be looking at lesson 4-6, which is basically a recap of what we did in yesterday's Zoom. So what we're going to be doing today is this is an edpuzzle. There is no delta math. Sorry, to have some water. And how it's going to work is there are 6 examples, and we're going to do all 6 examples, but throughout I'm going to be asking you a bunch of questions. So please pay very close attention. Some of these questions you'll be doing by yourself and typing your answer. Factor each of the following expressions using GCFLeftover. In case you forgot our steps, we find the prime factorization of each term in our expression. We then stack the rewritten prime factorization on top of each other. Highlight, circle, or box whatever is in common to each factorization. This is your GCF. Write your GCF on the outside of your parentheses and make sure you pay attention to plus or minus. So for our first example, we have the prime factor. We want to find the GCF leftovers of 8n minus 32. Please pay very close attention. We rewrite the prime factorization of each of our terms. So in this case, our 8n and our 32. So how it's going to work is we basically want to break apart our 8n. So when I break apart an 8, I can do it in a bunch of ways. I mean, just actually one way, actually. So I'm going to break it apart as 2 and 4. 2 is prime. I'm going to break apart my 4s, 2 and 2. So I can say 8n is equal to 2 times 2 times 2 times n. And the reason why I'm putting just one n is because it's an 8n. Now I need to break apart 32. 32 has a bunch of different combinations. So let's look at what 32 can be done. So you can do 2 and 16 or 4 and 8. I'm going to do 4 and 8. Just kidding, I'll do 2 and 16. 2 and 16. I can break apart my 16 to be 4 and 4. I can break apart 4 to be 2, 2, 2, 2. Highlight those primes. So I can say 32 is 5 2s. 1, 2, 3, 4, 5. Now we highlight what's in common. They both have a 2. They both have another pair of 2s, and they have another pair of 2s. So my GCF is just going to be 2 times 2 times 2, which is 8. So my GCF is 8, and now my leftovers which are going to be n, and then it's a minus 2 times 2, which is 4. So when I factor this, I get 8n, 8 times n minus 4. All right, now let's go on to our next example. I have 56b squared plus 48. I'm going to rewrite my terms. So I have 56b squared, and then I have my 48. 56 can be broken apart in a bunch of ways. I could do 2 and 28, 4 and 14, or 7 and 8. I'm going to do 7 and 8. 7's prime. Highlight it. And if you look over here, oh no, we didn't. Sorry. I can break apart 8 to be 2 and 4, and then 4 can be broken apart to be 2 and 2. Highlight your 2's. So I can say 56 b squared is equal to 7 times 2 times 2 times 2, and then 2 b's. Now I need to break apart 48. 48, I can do 6 and 8, 4 and 12, 3 and 16, 2 and 24. I'm going to do 3 and 16. Sixteen can be 4 and 4. And then 4 can be broken apart to 2 and 2. Highlight your 2's. So now I have 3 and then 4 2's. One, 2, 3, 4. Perfect. Now our next step, highlight what's in common. Well, if I look, they have a 2, another 2, and another 2. So my GCF is going to be 2 times 2 times 2, which is 8. So I have 8, and now my leftovers If you look, my leftover here is a 7b squared because I have a 7 and 2 b's. And here, my leftover is going to be, let's see, 3 times 2, which is 6. So my final answer is going to be 7b squared. It's going to be plus 6. And that's your final answer. All right, let's do the next example. Now I have to ask myself, how do I break apart a 25x to the 4th? Well, if I look, 25, I can break apart as 5 and 5. And I know 5 is prime. So I can say 25x to the 4th. I got 2 5s. And I have 4 x's. Now I have 15x cubed. 15, I can break apart as 3 and 5, and I know those are both prime, so I'm going to highlight them. So I can say 15x cubed is 3 times 5, and I'm going to write 3 x's. Now I highlight what's in common. Well, they both have a 5, and they both have 3 x's. 1, 1, 2, 2, 3, 3. So my GCF is going to be 5 times x times x times x. Which can be just written as 5x cubed. So I have 5x cubed as my GCF, and now I write my leftovers. Well, if you look, your leftover right here is a 5 times x, which is 5x. And right here, my only thing that's not highlighted is a 3. So my final answer is going to be 5x plus 3. So I get 5x cubed times 5x plus 3. Let's go on to number 4. In number 4, I want to do GCF leftover on 10v to the 5th minus 30v to the 4th. So 10v to the 5th. If you look, I can only do 2 and 5 on my 10. Those are both prime. So I can say 10v to the 5th equals 2 times 5. And I'm going to write 5 v's this time. So 1, 2, 3, 4, 5. Now I want to do my 30v to the 4th. Well, if you look, 30, I can do 2 and 15, 3 and 10, 5 and 6. Let's do 5 and 6. And I can break my 6 to be 2 and 3. Highlight your primes. So 30v to the 4th is equal to 5 times 2 times 3. I'm going to write 4 v's this time. So 1, 2, 3, 4. Highlight what's in common. They got a 5, they got a 2, and they got 1, 2, 3, 4 v's. 1, 1, 2, 2, 3, 3, 4, 4. So my GCF is going to be 2 times 5 and then 4 v's. So 2 times 5 is 10. I got 4 v's, so I can say 10v to the 4th is my GCF. So 10v to the 4th. And then I do my leftovers. My leftover in my first term is a v. My leftover in my second term is a 3. And it's going to be a minus 3. And this is your final answer. All right, let's go on to our next 2 examples. I have n to the 4th minus 2n cubed minus 9. So I can't do anything with my n to the 4th, so I'm just going to write down n to the 4th is equal to n times n times n times n times n. So 4 n's. To n cubed, I can't break apart a 2, so I'm just going to write 1 times 2 and then 3 n's. And then 9, if you look, I can only break apart into 3 and 3, which I know is already prime. So I can say 9 is 3 times 3. If you look, they have nothing in common. So I actually can't factor this. This is my final answer. Or if you want, you could just say prime. Let's go on to our next example. 72x squared plus 80x plus 48. Well, these are some bigger numbers this time, so let's see how we can break apart some of them. So the first one we're going to want to break apart is our 72x squared. So 72 I can break apart into a bunch of things. I'm going to break it apart into an 8 and a 9. 8 I can break apart into 2 and 4. 4 I can break apart into 2 and 2. Highlight your primes. 9 I can break apart into 3 and 3. Highlight those because those are prime as well. So I can say 72x squared is equal to 1, 2, 3, 3 2's. So 1, 2, 3, and then 2 3's. 1, 2, and then 2 x's. 1, 2. Now we're going to do our 80. And if you look, 80 has a few combinations. I'm going to do my 8 and my 10. So 8 and 10. You know, I'm going to do 5 and 16. 4 and 4. 2, 2, 2, 2. Highlight your primes. So 1, 2, 3, 4, 5. So I can say 80x is equal to 4 2's. So 1, 2, 3, 4, a 5, and 1x. Now we're going to do the prime factorization of 48. So I get, let's do 3 and 16. 4 and 4. 2 and 2. 2 and 2. Highlight those primes. So I can say 48 equals 4 2's and a 3. So 1, 2, 3, 4, and a 3. Now we want to highlight what's in common. So I have to ask you what's in common. I've got 1, 2, 3 2's in common. So 1, 1, 1, 2, 2, 2, 3, 3, 3. No other 2's in common. They don't have any 3's in common. So I have to ask myself, do they have any x's in common? They don't have any x's in common. So my GCF is just going to be 2 times 2 times 2, which is 8. So I get 8, and then I do my leftovers. So in this part, my leftovers of 72x squared are 3 times 3, which is 9, and then x squared, because x times x is x squared. Now I do my leftovers of 80x, which in this case are 2 times 5, which is 10, and then my x. And again, everything was positive in this. And then last but not least, my leftovers of 48. 2 times 2 is 4, times 2 is 8, times 2 is 16. Yep, that's right. 2 times 3 is 6. So this is my final answer. 8 times 9x squared plus 10x plus 6. All right, that's it for today. If you have any questions, email myself, Miss Townsend, or Miss Jimenez. Have a great day, ladies.